Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us solve a problem to find input impedance and standing wave ratio of a given transmission line. So here a lossless transmission line with the characteristic impedance Z0 as 50 ohm is given, which is 30 meter long. That is the length of the transmission line, and it is operating at 2 megahertz. The line is terminated with a load impedance ZL equal to 60 plus J40 ohms, and the velocity on the line U is nothing but 0.6 times the speed of light, that is c here. Now we are asked to find the reflection coefficient gamma, standing wave ratio S, and the input impedance. So first let us find the reflection coefficient, which is nothing but ZL minus Z0 divided by ZL plus Z0. We just substitute the value of ZL and Z0 here, and use the calculator in complex mode and divide the complex numbers and convert from rectangular to polar form. Why? Because for finding the standing wave ratio, it is we are going to take only the magnitude part, 1 plus magnitude of reflection divided by 1 minus magnitude of reflection coefficient. So standing wave ratio is a number only. Okay, it's a ratio of these two terms. And reflection coefficient is also a ratio, but it's a complex number. Here it's a real number since we are taking the magnitude of it. We have to find the phase and angle for the reflection coefficient. Okay, now to find the input impedance, we know that this is a formula, right? Input impedance of a lossless line is nothing but Zn equal to characteristic impedance Z0 multiplied by ZL plus J Z0 tan beta L divided by Z0 plus J ZL tan beta L. So here we are supposed to find the beta L value. ZL Z0 are given in the question, right? Now to find the beta L, we know beta equal to omega by u from the velocity formula, and beta L is nothing but omega L by u, with where omega is nothing but 2 pi f, okay, and L I am substituting, divided by u is nothing but zero point 0.6 times the speed of light. So 2 pi f is 2 megahertz into 30 meter, the length of the transmission line, divided by 0.6 times the speed of light, that is 3 into 10 power 8. So after substituting, we get the answer as 2 pi by 3, which is going to be 120 degree. So in this formula, we are going to just apply as tan 120 degree. Okay, rest of the terms ZL, Z0 we can apply directly. After finding the expression, we need to divide in the calculator by using a complex mode and convert the answer. This is a rectangular form, right? After getting the rectangular form, we need to go back to the polar form, and from that we can come back to the rectangular again. So the answer is a complex number for input impedance since it involves the J term. So the final result is in ohms. So for a given lossless transmission line, characteristic impedance, load impedance, okay, the length of the line, okay, to find the beta L, we need the frequency and velocity. All these things we substituted and found the input impedance, and only with the help of Z0 and ZL, we are able to find the reflection coefficient. From the reflection coefficient, we are able to find from the magnitude of it the standing wave ratio. I hope you understood how to solve a problem based on this. The same problem we will solve by using a Smith chart, a graphical tool, without incorporating the formulas and in a simple way. Okay, we'll see in the next module that. Thank you everyone.